All right, hello everyone, and welcome to the final, basically chapter, which is vaccines. So this is basically a presentation that I actually got from my supervisor, Vincenzo Cerullo, but of course I've edited a couple of slides there and there. So why I really stole it from him? Because Vince is one of the most, let's say, he's the biggest experts when it comes to vaccines, specifically cancer vaccinations. So that's why I took it from him. He has really good slides, and he's one of the literally has a good insight into vaccines. So the objective of this lecture. So we're trying basically to understand to you what vaccines are. So when it comes to a vaccine, the biggest goal of it is to actually give you a long-lasting and protective immunity against a pathogen, whatever you're trying to vaccinate against. So we're trying in some sort of way be able to give you some protection that when you're exposed to whatever virus you're being vaccinated against, you do not get the disease, and even hopefully not even get the virus to replicate within your system, but more importantly, not to get the disease. So basically, you need today we're going to definitely talk about immunological memory, different types of vaccinations, and the novel vaccine developments that there are currently, specifically the ones that we saw during COVID. So, if you look at the history of, in general, vaccination, it really goes back to almost 2,000 years ago, specifically in the Peloponnesian War. So, where you basically started to see the plague outbreaks in Athens, and we started to see some sort of vaccination kind of effects. When you had these the plagues kind of outbreaks, you saw that some people were actually surviving the second plague because of a memory, and that was the first, let's say, kind of description of a vaccine-like effect. But then a proper vaccine that was really developed was actually against smallpox, specifically this variolation. And that was basically mostly, coming from Jenner. So of course before it there was some sort of like practice in some sort of way, but let's say the proper vaccine really came from Jenner, and he was the one that he came up and actually came with, how can I say it, the proper vaccine. And if you want to know the story behind the vaccine development or of Jenner, it's actually quite a gruesome story, because if you think about it, what Jenner did, what he saw was that milkmaids. So these are basically women that were milking cows. They were actually had a quite a less susceptibility to being infected with smallpox. Smallpox during that time was a very, very nasty viral, basically kind of infection that could kill you. It was severely lethal. And he saw that milkmaids were actually protected against smallpox. They did not get actually any disease. So he thought, it's like, okay, most probably what's happening is that these cows have cowpox. So it's basically a similar virus to smallpox, but the cow version, which in generally, if infected to humans, doesn't do much to us. But because of it, we get some sort of immune response that we're able to actually kind of protect us against smallpox. So, as a proof of concept, hence what POC means, basically Jenner got, one of these kids from the milkmaids, this James Phillips or James Phipps. I don't think he was either the kids or one of the milkmaid or one of the basically kind of maids just in the house. He took him. He literally got one of the basically a pus, so these cows that had cow pus, took the virus or isolated the virus from there and injected him in basically James Phipps, this little boy. He then took James Phipps and he threw him in the middle of literally a room filled with people who had smallpox. Was that ethical? Hell no. But basically nowadays you're not allowed to do that. But back in the days, you were not allowed. You were basically there was no ethical committee. So technically he came up, and yeah, it actually worked. This kid actually did not contract any smallpox. Hence, he basically Jenner proposed the name of vaccination. Vaca basically means cow in Latin. So, and also in Spanish as well. So hence vaccination came from that. So that's where the roots of vaccination, the word of vaccination came from. So this is the smallpox that we're talking about. It really caused these really like blisters all over your body, and it was extremely, what do you call it, deadly. Of course, this was a letter from basically from Thomas Jefferson to Edward Jenner, who discovered basically the vaccine. And he was telling him, "You have erased this calendar of human afflictions, one of its greatest. Yours in the comfortable reflection that mankind can never forget that you have lived. Future nations will know by history only that the loathsome smallpox has existed and by you has been extirpated." So honestly, it's a beautiful way of saying it. Yes, because of James, basically Edward Jenner, as gruesome as his experiment was, as much as that he actually not funded, but created such a huge and revolutionary science with immunology, which is vaccinology. Because of him, we managed to see that we can actually protect ourselves against lethal pandemics, epidemics, viruses that we get exposed quite often. So it was a huge breakthrough. And of course, this is, let's say, the year of smallpox, around that time that we started to get basically literally vaccines. And if you look at the vaccines, really, it was only until around the 1860s, 1870s, that we started to appear much more different types of vaccines to the point now there's plenty. So Edward Jenner really was, let's say, the one that kind of, his idea wasn't that really kind of taken up only literally hundreds of years ago later that it started to really boom everywhere. And nowadays, we basically have so many commercial vaccines commercially available for us. And of course, nowadays in our health ministries, we do have some sort of program that we need to get vaccinated with certain, let's say, vaccines throughout our childhood and also adulthood, which are very important to help us protect us and not basically die from preventable infections. So if we look at basically all the commercial vaccines, so these are basically a list of them. So these are, let's say, the amount of people that actually have taken that have taken or basically have actually had cases. So these are basically so people that have had the vaccine and then had a case of infection. And look at the deaths. Quite minimal. You put the percentages, none of them are literally coming next to the 10%. Not even 1% even. To show you how good these commercial vaccines have been really in preventing very deadly diseases like smallpox, poliomyelitis, measles, mumps, rubella, tetanus, these things that used to back in the day really kill us. So just to show you the efficacy of vaccines. But how do vaccines work? So what is an immune response? What is the difference between a primary and secondary response, and why we need vaccines? So let's first talk about the most important principle of a vaccine, which is primary versus secondary immune response. So let's imagine that we get exposed here for the first time ever to a, let's say, a certain virus like influenza. We get infected with influenza, we have basically a primary immune response. So the x-axis is the time, while the y is the concentration of antibodies that you produce. So we see that basically the first time we have, let's say, 10 milligrams of antibodies produced. The second time that we get exposed, basically with influenza, the same one that we got exposed initially, we get basically from 10 now to 50. So this is what literally is a vaccine response, in a sense where the second exposure, first of all, the timing is much quicker. So if you look at the timing, it's much more quicker, the response, and the magnitude of your immune response is much greater. So faster and greater immune response. That is basically vaccination. So basically, this is what's super important, that what we can do is prevent. So when we get basically our first exposure, let's make sure that first exposure is a vaccine. It's a vaccine that literally looks like whatever virus that you're trying to protect yourself. For example, let this be influenza. So you have the small little basically antibodies, but this basically when you actually really get infected with influenza, it mimics this secondary exposure because now you have some sort of immune response, and that's memory. Because of memory, we get this faster, quicker, and more, let's say, stronger immune response. So if you really want to, let's say, kind of define vaccination at a simplest form, it's the administration of antigenic material to produce immunity to a disease. You're literally injecting some sort of material from whatever basically you're trying to protect yourself. And that has to be antigenic, meaning antigenic means something that is able to produce an immune response. And you basically, hence, you're trying to protect yourself from a disease. So vaccination is exposure to a pathogen or antigen. So in a way that you actually acquire an immune response. So this acquired immune response, first you have your innate immune system should be activated, and it's specifically your antigen presenting cells, which are your, for example, dendritic cells. So your dendritic cells come in, they pick up whatever pathogen you're actually vaccinating, or antigen or small piece of protein from the pathogen that you're infecting, and the antigen, basically the dendritic cells, are going to come up, eat it up, and then present it to your T cells. Because your T and B cells are the only immune cells in your system that can adapt or produce an immune response, or sorry, a memory response. So vaccination really kind of is mostly centered around T and B cells, because these are the ones that are able to become long-lived memory cells. And where the second exposure, so the real exposure, let's say, of the viruses before, so after vaccination, you have these circulating, long-lived memory cells that are literally able to protect you and produce a T cell response and a B cell response, so mostly your antibody response, to go and kill your pathogen that you're being infected with. So what does a vaccine actually, what is it made of? Well, a vaccine is made of two things. Literally, it's super simple. It's an antigen, whatever piece of protein or whatever pathogen you're trying to vaccinate it against, and an adjuvant. An adjuvant is literally something that attracts your immune response. So your vaccine has to have both of them. So if you inject just the antigen, the immune response is not going to come up and pick it up. Actually, most likely your antigen will be cleared out from your system. So they have to be combined together. So an adjuvant, really what it does, it brings your immune system towards your antigen to be picked up. So let's imagine this is your vaccine. As we said, you have your antigen, and then you basically, which are these little circles, and these triangles are literally adjuvants. What are these adjuvants? They're PAMPs, they're DAMPs, things that stimulate your immune system to come in. For example, they can stimulate your dendritic cells to come into the site, or it can stimulate, for example, neutrophils, macrophages to release a lot of cytokines, which bring dendritic cells to your site that you're vaccinating. So they're there, they come there. The dendritics come in, they can be basically even further activated by the adjuvants. They pick up your antigen, and then they present it to your CD4 T cells and CD8 T cells. The CD4 T cells really help quite a lot B cell formation, and your CD8 T cells creates the cytotoxic T cell response. So you have your cellular and your humoral responses. But along, you always have memory cells. So you have either CD8 memory cells and basically memory B cells. So what happens is that let's imagine this vaccine is against influenza. When you get infected with influenza, these are already there. This whole process does not have to occur, because this whole process can take about 1 to 2 weeks. So it takes time. Well, basically for them to start creating antibodies and basically T cells can be almost instantaneously. It can take a couple of hours mostly. So this is what the vaccine really is based on. So characteristics of vaccines is extremely safe. So honestly, this movement of anti-vaccination is something that I will never understand in my life, because it's purely people that are trying to literally fit a square toy in an opening that's circular. So literally you're putting a square, you're smashing it against something that is circular. It's not gonna,